Yeah.
Okay, thank you. I think I just shared screen here. Okay. All right, so if you guys want to, you can open up a 3D project, and we're going to be making a tower defense, a really basic tower defense game. So we plan to do this in 2 parts so we could focus more on like building it out, but since we only have 1 left, we're just going to try and put it all into one. So if you look, this is the sample one. Recognize. And if we hit play, I already set turrets up, so there's 2 kinds of turrets. This white one shoots normally, and this blue one's like a sniper. It does more damage, but shoots slow. And then every few seconds, a new wave of enemies will spawn. Everyone can see my screen, by the way, right? Or no?
Yes,
Okay.
we can see it.
Okay, cool. So this is and then potentially if we have time, we can add in extra enemies and change what spawns. So like each wave spawns a different variation of enemies. The red ones are harder to beat than the blue ones. All right. So now to get started, this thing's in there. All right, so you can open up a new scene with a 3D project, and whoops, no, sorry. All right, so we create a new 3D project, and what we want to do first is we need to create a ground for the actual level to take place on. So I am just going to create a 3D object cube, and then just scale it up. Let's just do 20 by 20. I think this is the right way. 20 and 20. And then reset its position back to 0, 0, 0. There it is. All right. So, and while I'm at it, I'm going to position the camera just so I can see the entire level at once, just so we can do this and we'll have to worry about it later. So let's move it up. You can use your game viewer, the camera preview, to kind of see what your camera's looking like right now. And I'm gonna use control to snap by units. I think we may have talked about this before, but like right now, if you're when you try and move it after you rotate, your arrows are either going to look like this or like this. And if you want them, if it helps to have them oriented globally rather than locally like this based on the actual object. And if you want to switch to that, the option, you can click it, and then we can move it by global coordinates just to keep scaling it better this way. I think that's the entire level. Yeah. All right. So now I have the entire level. Let's call this ground. And then I'm going to give it a material now. So I'll create a new material. You know what? I have all these assets here. I should make a new folder and redo them. All right. So we'll call this walkthrough. So create a new material. You can make it any color. I'm just going to put all my new assets in a folder since I already have these assets. But let's see, create material. I'll call it ground since it's going to be my ground asset. And then I'm just going to make it a kind of grayish color like that. It's probably fine. I don't like the shine, so get rid of the shine and drag it onto the ground. This is just going to help because what we're going to do next is create kind of a walkway for the actual like enemies to traverse through. There's kind of a lot of different ways you could do the enemy movement for this tower defense, but I think the simplest one we can do for this tutorial is just going to be defining a set path for them to walk through. So let's mark that out. So I'm going to create another cube. Let's call it pathway. Let's reset its position back to 0, 0, 0. I'm going to use control to snap it easier, to remove it by units, I mean. That way they kind of line up. I'm going to scale this down a little bit too, is actually. There we go. All right, and now let's just stretch it out. That's probably fine. You can put them however you want. I'm just going to make a pretty simple kind of path. So let's put one block here. I'm going to duplicate it. Let's rotate it by, pretty sure it's X, 90. Nope. Y. I'm going to rotate along the y-axis. Let's shrink it down a little bit over here. And then duplicate this one. And this is going to be my path just for the sake of time, but you guys can go ahead and make any complicated paths you want. Like if you get ahead or something, you can always just go back and continue working on your path. So here, this is the pathway that I'm going to be using for my level. And to help, I'm going to create an empty object. Let's reset its position. And I'm just going to call this pathways and put them all into this one. So let's select them all, drag them into pathways. All right. So now we should have a ground for our level to take place on. Our camera should kind of be set up to look at the level. Mine's kind of in a weird angle. Let's move it forward a little bit. There we go. And then we have a pathway for our enemies to walk on. But our enemies need so we have these cubes for visually, but we need a better way to actually program how the enemies are going to walk through it. And the way I chose to do it was through kind of like checkpoints. So actually first I'm going to create a spawn point and an end point for the enemies, just so we see it. So let's create another cube. I'm going to call this one start. Let me reset its position. And then just choose one of these spots to be the starting spot. So it'll start over here. Pull it up. And there's my start. Let's duplicate it. Call this one end. And pull the ends over here. All right. But these kind of blend in as well. So just for the sake of things, you can create more materials. So I already have a few materials. I'm just going to use those ones again, but you can create more if you want. You can create your own. So for example, for start, I just have this green one, and end, I just have this red one. And there. Now we have a start and an end. So now let's go back to that checkpoint kind of idea. Okay, so the way I'm going to do it is just with an empty object, because all I really need is the checkpoint is just going to be a position that the enemy can traverse through. So what we kind of want to set up is, since it's just straight lines, we can just have our enemies move in certain straight lines along the path, and we'll just give them these checkpoints as basically when to change direction. So I'll call this one checkpoint. Let's reset the position. And
is
then
the checkpoint an empty game object or is it another cube?
It's an empty object because we don't need it to have a model or anything. This is just, we only need it to have a transform. So all it is an empty object. To help see it, there's this box here on the inspector. It looks like a cube right now. If we click on it, you see these different colors and icons. We can select one, and now if you look at it, we can visually see where it's called a Gizmos. So we can assign one, basically like an icon just to represent where it is visually for us. And if you notice in the game view, it's not there. This is only for the scene view. So like if you need to visualize where your empty objects are, so now it helps kind of place them along the path. So let me get its height, pull it up one more. And then I'm going to place it along the path. There, so that's about even. I'm going to duplicate it, pull this one over to here, and then I'm going to duplicate it one more time and pull it in and put it inside of the finish. You don't need one in the start, just because once they spawn, we're gonna set that as a spawn point. So I mean, you could make another empty object and put it in start, but you don't need to because we can just use the starting block as that.
You put it in the middle
But
of
now
the
we have
finish?
these. Yeah, you can just put it right inside the middle finish cube.
Okay.
And once we have those, we are going to create another empty object. And this one we're going to call, let's reset its position. We're going to call this one checkpoints because it's going to hold all of our checkpoints. And then we're just going to grab all of the checkpoints we have and drag them into this empty object. Okay. So now we should have a ground object. We should have an empty object storing all our pathways, however many you wanted. You can set up as many as you want. We should have a start block, an end block, and then another empty object containing all of our checkpoints. And our checkpoints are just empty objects. There's nothing really in them. So now what we want to do is we're going to create a script on the empty object that stores all of our checkpoints. So on the checkpoints object, we're going to create a script. I'm going to call it checkpoints. Create an add. Because we want this, and let's open it up. Let's see. There it is. So we want our checkpoints to be able to be accessed by our enemies when they're moving through. And so what we can do is we don't need start and update, so we can delete these. And then what we're going to do is create a public static array of transforms. And we can just call those points. So we haven't used the word static before, and it basically allows our array of points to be accessed by all of the scripts, no matter the scope. So our other scripts that we create after this point will be able to access the checkpoint script and access this array. That's all we kind of really need to know about that for now. And then, but we need to initialize that array. So what we're going to do is write void await. We'll say points is equal to a new transform array. And this is where we specify the array size. So we are going to write transform dot child count. Oops. All right, so what this is doing is we're creating a new array based on, so this script should be on the empty object. And the reason why is because it's going to access the empty object it's on and then count the number of children there are. So like my empty object, you can go back and look. My checkpoints object has 3 children because there's 3 waypoints for them to complete the level. So that count is just going to give me the number 3, count how many children there are. So I get an array of size 3. And then what I want to do is initialize each of those specific points. So we're going to do it with a for loop. So we'll go for integer I equals 0. And we want the condition to be as long as it's less than the length of whatever points is currently. So points dot length. And we just iterate through. And we take the I element of points, and this get child is a function that will get what it will iterate through each child. So this will get like the first or the 0th child, then the first child at 1, child at 2, and assign that transform to this points spot. So we can save this, and this will initiate our checkpoints array, and we have it accessible by all of our other feature scripts. So that's all we need to do for this script. This script's done. So we can go back here. And there shouldn't be any compiler errors or anything. Okay, now the next thing we want to do. So we're going to, let's see, can I go back to the code? Yeah. Just so you know, again, if you end up falling too far behind or something breaks and you need to look back at the code and I'm too far ahead, that package I sent you has all the completed code. So you can just compare your script to the ones that are in there just to see, or just ask a question. But just in case you guys fall too far behind, I know we've had problems with that before. So, all right. So the next thing we're going to be doing is creating enemies. So I think if everyone's good with this script, I'm going to go back to Unity. And I'm going back. All right. So our enemies are just going to be, let me create a sphere. I'm going to make it slightly smaller just because this full size is kind of big compared to the rest of our level. So I'll just cut it in half, 0.5, 0.5, 0.5. Let's just put its position back to here, pull it out. And then you can create a material for this too. I think I already have one as well, but you can make your own. So I have this blue one. Let's put it on here. I'm going to rename this enemy. And then what we're going to do is, once you have this enemy, all it really should have, it should just be a sphere. You can change its position or scale or whatever, give it a material, and then drag it into the project tab and make it into a prefab. I realize there might be an issue here because I already have a prefab named enemy. So I'm actually going to rename mine opponent, but just in case that causes an issue later with my other prefab. Okay, so mine's called opponent now, but yours can be called enemy or opponent. Now let's see. Once we have that, we don't actually need the opponent to be in our scene anymore, so we can delete it. We're just going to work through the prefab. So like if you click on the prefab, the inspector will pull up all of its components and we can add components through this prefab. All right. We're actually going to put a hold on the opponent and create a spawner first. And then we'll do the actual opponent scripts. So we want to create kind of an object that will handle spawning our enemies as in waves. So we could do that through like a start or something, but I'm just going to create an empty object and call it game controller.
Jared, someone asked for you to go back to the code in the chat. I don't know if you read that already.
Well, this was a while ago.
We're good. Thanks, Cade, though.
That was 3 minutes ago, was it not?
Oh,
that was me. I already got it. Thank you, though.
Oh, cool.
All right. Thanks, Cade, though. Yeah, I can't really see the chat, so if something comes up, feel free to.
Did you just make an empty game object?
Yes, this is an empty game object. I'm just going to call it game controller. And now we're going to create another, this one. So let me see. I'm going to create a script and call it opponent spawner. Create an ad. All right, opponent spawner. Let me pull up my note real quick. So I don't think we need these, so you can go ahead and delete the start and update, but if we do, we'll just add them back. And first thing we want to do is we want to let the game controller know what type of enemy to spawn. So let's give it create a public variable called public transform, and we'll call this opponent prefab. We also, in a tower defense game, there's normally time between waves, so we're going to want a timer for that. We'll make this one public too, just so it's easier to change while you're in the inspector, in case you want to extend the time between waves. So that's why we'll make it public, and it'll be a public float. public float. We'll call it time between waves. Let's just do 5 seconds for now. And then we also need an internal timer because normally like we don't want all the enemies to spawn on top of each other. So we want some kind of countdown to happen within this script to space out the spawning of all the enemies. So let's create another float variable. This one will be private. You could make this one public too, but I'm just going to make it private. Countdown. And I'm just going to set it to, actually, no, this private, sorry, I explained this countdown variable wrong. This is the, we do want this one to be private for sure, not public. Okay. And then when we actually iterate through and create new waves, we want some kind of number to keep track of what wave we're on. For example, like you don't want the spawner to spawn the same number of enemies each wave. You want the game to get progressively harder, right? So we need to keep track of what wave we are currently on. So we can do that with a private integer, call it wave number, and set it to 0 since at the beginning of the game we're at wave 0. Okay. So now we actually do need the update function back. So I'm going to write void update. And let's think. So what we want to do is we want to have some kind of function, right, that will spawn the wave. So we'll just create this for now. We initialize it after, but let's just write spawn wave here. This is the function that's going to do it, but we don't always want it to just spawn wave. Like if we just have this code, it'll just spawn the wave every frame. So let's create an if statement. We only want it to spawn the wave if our countdown is less than or equal to 0. All right. I'm missing one, aren't I? All right, so if our countdown's less than 0, we want to spawn the wave, but our countdown isn't actually changing here. So decrease. So we'll just
Jared, you're cutting out.
countdown minus equals. And we're gonna, I don't know if, am I good? Am I back? Oh, my internet connection's unstable.
Oh yeah. Yeah, maybe you should turn off your video.
Okay. All right. Am I back? Can you guys hear me?
Yeah, I can hear you now. But you have to give us a second to type out the code. Okay, yeah.
Yeah.
like,
So right
you're,
now.
you're good now.
Okay. I guess I'll quickly explain what we just did again, just in case I don't know how much we missed. But so we create a public transform variable just so you can put where we can give this object to the enemy we want to spawn. We created 2 floats to act as timers. The first one is going to be a public float that's going to keep track of the time between waves, and the second one is going to be a private float because it's one that is just going to be dealt with internally in this script, and it will be kind of the way it keeps track of how much time has elapsed. So we just call it countdown and set it default to 1 second. And then we have a private integer called wave number, which you just keep track of which wave you're currently on in our game. And so in the void update function, we want to spawn wave whenever the countdown's less than or equal to 0. And then we're back to where we were before. So we want to decrease countdown by time dot that changed, didn't it? Time dot delta time. Let me write it back. Time dot delta time. I don't think we've used this before, but basically what time dot delta time does is it takes the time that's elapsed between the last frame. So different computers run at different frames per second, right? We'll run the game at different frames per second. So if we just had the countdown go down each frame, then people with really fast computers, the countdown would end really quickly. While those with slow computers, it would take a lot longer. So when we do time dot delta time, it kind of standardizes that so that everyone's countdown will go at the same speed, no matter your computer speed. Does So this is what we want here. Oh, forgot the semicolon. And now let's define what spawn wave is, since we wrote it above, but haven't. Void spawn wave. All right, so now what we want to do in spawn wave is we need it to create, it needs to basically initialize how many, it's gonna create the enemies. So there's different ways you can do it, right? Like there's more complicated ways. So for example, if you wanted like 5 enemies to spawn on wave 1 and then like 6 on the next wave or like 10 on the next wave or something, it's gonna depend on, I guess what we write in here is gonna depend on how you actually want the gameplay to work. The easiest way for us to do this is just to have it spawn the amount of enemies that a wave number amount of enemies. So like if we're on wave 1, we'll just spawn 1 enemy. If we're on wave 2, we'll spawn 2 enemies. That's probably the simplest to implement, but there are a lot more like complicated ways you can do it, and there's probably more user-friendly ways as well. So we're just going to spawn the same enemy, have that number of enemies spawn depending on what wave number it's on, what wave number it is. So what we want to have is, first we want to increase wave number. So every time this function is called, we will increase what wave it's on, or the current wave number we currently are on. And then we want to have a for loop. This is going to be less than wave number. And now we want to spawn the enemy. So I'm going to create this as another second function just called spawn enemy, just because like in the future, if you want to differentiate the types of enemies you would spawn, it might be helpful to have it as a separate function rather than just hard coding and like instantiate this object here. So we'll create a function called spawn enemy, and down here we will define it. So void spawn enemy. So spawn enemy, we're going to have it taken a transform, which is going to be our enemy prefab. So let's just call this enemy. And then the way we would create that new enemy, a new instance of our enemy prefab would be to use the function instantiate. Instantiate, we give it the object we want, or we give it the transform we want to create. And then we need to give it a position and a rotation. So we could just give, this is where we're going to need some kind of spawn point. So back at the top here, I'm going to create another variable. Let's do it under the opponent prefab. I'm going to call it public, another transform, and this is spawn point. Okay. So now we should have a public transform for the opponent prefab and a public transform for the spawn point. So now back to our instantiate function, we're going to take the spawn point, and we want its position, so dot position, and spawn point dot rotation. Once we have that, we have our spawn enemy function. Okay. So there's going to be kind of an issue here, because if we, all right, well, let's just play it, see what happens. So if we go hit save it. Oh, yeah, I forgot to give this here.
Is enemy not in our hierarchy?
Oh, you mean the actual object in the?
Yeah.
Yeah, so we don't actually need an enemy to be in our hierarchy, because what we're going to do is, if I find my game controller, you'll notice the spawner script is now here, right? Opponent spawner, and it's asking me for an opponent prefab and a spawn point.
Oh, mine doesn't ask for that.
As long as if you have public transform, it should be there.
Yeah, I do.
Okay.
Love that for me.
Um,
Well, if you want to go to the tutorial,
Okay,
Can
where I
all-
usually am.
sorry, Emily. Okay, so if I'm assuming we have that, the opponent prefab and the spawn point, what we will do is let me find where my prefab is. It's right here in my project folder. I can drag my opponent into the opponent prefab. And then for a spawn point, we could create another empty object for that, but I'm just going to use the transform or the start object. So now we have the opponent transform here and the start transform here. And now I think that's everything. We should be able to hit play and, oh, let me not maximize on because we want to see what's actually happening. All right, so now if you look at my hierarchy, we just created, okay, let's take it back. I messed something up. So we have the private int wave number equals 0. Wave number goes up, void spawn wave, if countdown is less than 0. Oh, yeah. So countdown goes down here. I guess I was going to try and demonstrate, but the demonstration doesn't seem to be working. So I'm just going to explain what's going on wrong and how to fix it. So what we actually need to do, because when we want to spawn the wave, this is just going to spawn all of the enemies at basically on top of each other. It's not going to take into the account the time it takes between spawning enemies. So in order to add that in, we would need to create basically another timer variable and have it count as well. But that would mean it would be trying to, let me get my notes just to, okay. So they would be trying to count both at the same time. It wouldn't really be able to do that. So what we want to do is, sorry, is there a question in the chat? Oh, never mind, sorry. All right, so what we want to do is create something called a coroutine, which is actually I think what the advanced tutorial is doing in probably a much more better way. But so I'm going to write the oh, I see what I didn't do before. In the void update function, we want to add this line. And then I'm going to write down what we do to make it into a coroutine so that the two timers can run simultaneously. So first you want to set countdown equals the time between waves. So every time we spawn, we can create time between waves. And this actually will help demonstrate it better. So with that line, I can hit play. And you'll notice one opponent spawned. And it's not really moving. And the other one's instantly spawn as well, instead of taking time between spawning. So we want to create that to take time between spawning. So what we will do is, instead of calling this void, what we're going to call it is IE numerator. So write this keyword instead of writing void. And then inside of our for loop, after we spawn the prefab, write this line, yield, return, new, wait 4 seconds. And then we're just going to give it 0.3 of a second. You can make this anything. If you want it to take like half a second to spawn each enemy in the wave, or like 0.1, whatever you want, you can set to whatever. I'm just going to do 0.3. And then because this is now a coroutine, we can't call it like a normal function. You use this instead. So we say start coroutine. And then we put the name of our coroutine inside of that. So just to kind of recap, first I added this line. I said countdown equals the time between waves. That way, every time our countdown hits 0, it gets reset back up to 5. Next, I changed spawn wave from saying void into IE numerator to make it into a coroutine. I added this line here, which is going to make it wait a certain amount of seconds before it spawns the next enemy, or basically before it completes the for loop. And then I added this line here when I call the function in update. Yeah, so that's actually a good question, Alex, because if we're going to flesh this game out fully, you would probably want that, but because this is going to be really small, we don't actually need to worry about it. But yes, if you wanted to make a full like tower defense game, that would definitely be a problem you'd have. Because the enemies just start spawning on top of each other if our time between waves is always 5 seconds. For example, if it took more than 5 seconds to spawn the number of enemies, then they'd spawn when the next wave started spawning. So you would want this to increase, but we're not going to worry about it for this scope of this tutorial. All right, are there any other questions so far? What is the return value for wait for seconds? I think it's complicated. It's just different. I don't think we're gonna spend a lot of time explaining that now for this tutorial, just because we don't have a lot of time. But afterwards we can probably look into it if you want, if we finish everything. Yeah, like I said, sorry, this tutorial was supposed to be multiple weeks, but since we only have this 1 week. All right. If that's all, we're going to move on. So saving this script, we can go back and we can hit play again just to see. And so our first opponent spawned and we wait a few seconds, the second, and then you see there's more of a gap now between them instead of spawning basically on top of each other. So that's kind of what we want to happen. All right, so now we actually need to give functionality to our opponents. So we can go back to our enemy prefab that we currently have. And we need to add a script to that. So I don't think I created opponent script yet, did I? No, I did not. So on my prefab in the projects folder, what I'm going to do is add a component, a new script, and I'm going to call it opponent script. Or if yours is called enemy, you can call it enemy script opponent. Create an add. So now my prefab has the opponent script. Let's open that up. And let me pull up a new notes. Okay. So we can think about what we kind of want for our enemy. We want it to have a speed that's pretty easy to access. So let's create some space and let's make a public float called speed. Set it to 10. This is just an arbitrary number. It'll probably, I don't really know if this will be too fast or too slow. We can see when we actually get into the game, but you can set it to whatever you want. And because it's public, we can just easily access it from the inspector rather than having to hard code it. We could give our enemies a health bar, but for now we're just going to have it be like a 1-hit kill, and then we can add health later if we have time. So we're not going to worry about health. So if we remember when we created our scene, we created these pathways or checkpoints. So we want our enemies to have a target kind of checkpoint that it's going to, so it knows like a destination for its path. So we're going to create a variable for that in the script. We'll call it private transform target. So this is the target transform it wants to move to. All right, and then we also are going to have an integer checkpoint counter just so it knows which checkpoint it's on. All right, and now in our start function, so if you remember when we created our checkpoint script, we made it static so it could be accessed. And so now here we can just access it. So we can set target equal to checkpoints dot points and the first one. So because we have set to public static, we can just access it straight up here. All right, so we initialize our first target as the 0th item in our checkpoints array. All right, and now in our update function is where the enemies are actually going to move. So let's create a vector 3 called direction. I don't remember if we talked about vectors in our past tutorial. I think most of them were 2D, but if for those who don't know, a vector is kind of just like an arrow, like it has a direction and a magnitude to it. So we're going to create our vector 3 and call it direction. And the way we figure out which kind of direction we want to move is by taking the target's position. So we can call it target.position and subtracting it by our position. So our transform dot position. And this will give us kind of the arrow pointing from where we're currently located to where the checkpoint is located. And that will be how we know where to move. All right. And so now what we will do is there's a function called transform.translate. So I think normally we do movement by adding forces, but for this, we don't need to worry about that. We're just gonna move our objects using its transform through 3D space. So because it's a simpler project, we can use something like that. But like generally with player movement and stuff, you would use adding forces instead. But so we'll do transform.translate. And this needs to take a direction now. So what we're going to do is give it the direction we just calculated, and we're going to type dot normalized. And the reason we're doing this is because, as I said before, a vector has a direction and a magnitude, and you can kind of think of a magnitude as a speed. So when we calculate this direction, it isn't just the way we want to move, but it also kind of it has an implied speed along with it. And we only want the speed to be more, we want the developer to have more control over the speed. So by typing normalized, it sets that magnitude to 1. And then if we multiply our vector by our speed variable, that will give us more control over like how fast our object moves rather than having it just be baked into the direction. And then once again, we're going to type time.delta time here because we don't want, we want our objects to move at the same speed no matter what computer you're on. I think that should be what we need here, so we can close that. And then the next line is we need to figure out, I guess we can play to see if this works so far, if I didn't forget anything. So now if we hit play, our opponent spawns and it goes to that waypoint and then it just gets stuck on the waypoint. So this is currently how we have the functionality we have for it. So it's working correctly. You notice it's kind of hovering. And the reason it's hovering is because it's kind of complicated, but the way the frame where it's moving for each byte on each frame, but it's moving kind of a different set amount of distance each frame. So the chance of it actually landing exactly on the waypoint are pretty small. So what it's doing is just keeps continually overshooting, and it's overshooting so many times that it wobbles back and forth. And that's kind of important because when we want to set it to go to the next waypoint, we have to take into account that most likely our enemy's transform won't ever exactly equal the waypoint's transform. So instead, we want to check to see if it's within a certain range rather than to see if it's actually equal to the checkpoint's transform. So let's create an if statement to check to see if it's basically reached the checkpoint. And we're going to do vector3.distance. So this is a function that if you give it two vector 3s, it will tell you the basically just the distance between them. And this will allow us to perform our check. So we're going to give it our position, transform.position, along with the target position. And we want to check to see if that is, this variable is kind of arbitrary too, and it's going to depend on how fast your player is moving, but basically 0.3 should be about enough. So if you check to see if it's within 0.3, like whatever units that is, it should work. And now we're just going to make up a function, call it next checkpoint, and we'll define it here. So this will call the function next checkpoint, and that function will set whatever our next checkpoint will be. So we'll create a void next checkpoint. Oops. And then we want to have it iterate to our next checkpoint. So what we're going to do is first we need to increase our checkpoint counter to let it know that it has hit the next one. It's going to the next checkpoint. We then want to set a new target. So we'll set target equals to, what is my variable called? So checkpoints, again, we're accessing the static script we have earlier, dot points. And this will be whatever our waypoint counter or checkpoint counter is currently on. So now this would work, but we need to check to make sure it doesn't go out of bounds. Add a quick if statement here where so if the checkpoint counter is currently greater than or equal to our checkpoints dot points dot length. So this is the length of that array minus 1. If it's greater than that value, we know that it means it's hit the last checkpoint. And the reason it's the -1 here is because I think it's just because things start counting from 0. So the 1 is just to keep track of kind of that relation. But once we have that, we hit destroy. We want to destroy our current game object because it means it's hit the end. And in like an actual tower defense game, this would mean you would take damage and then the enemy would vanish, right? So we're gonna make it vanish. We're not really gonna do like have it deal damage to your health bar, but if we have time, maybe. And then the reason we put return here is just because we want it to end. So sometimes destroy can take a while to finish, and it will try and access. It will keep running code while it's actually destroying the object. And so if it continues to run the code, it'll try and run this line when we're out of bounds, and that'll cause an error. So if we hit the return statement here, it'll return from this function while the destroy is taking place. So that way we don't end up with any out of bounds issues. That's why the return is there. Any questions so far on the opponent script? Are we good with all of these lines? We have our update function, which translates us to the nearest checkpoint, and then our next checkpoint function, which iterates through to keeps track of which one we are on. And if we have that, we can go back to our scene. Whoops, there it is. We hit play. And now you notice our enemy does move to the next one, and it vanishes from the hierarchy once it hits the finish. So they move to the next checkpoint, and then they vanish. Yes, question. If you theoretically have an error called assert. All right, so we're about halfway through the tutorial. I think we're doing good on time. So now that we have our enemies, now we actually want to create a turret. So the reason why I did 3D is just because it's really easy to make assets. We can just make there's our turret. It's going to be a cylinder. So we'll rename this turret, and let's just put it back to 0, 0. Just place it wherever you really want to. That looks fine. And then I don't think we actually need like a collider or anything, but it's fine. I guess that it has it. We're going to add a turret script. So let's create a new script. I think I already have a turret script defined, so I'm just going to title mine something else.
I think your screen is frozen, Jared.
Is my screen frozen?
Or oh, okay. It's catching up.
I have probably my internet.
Oh, did you just call it? Did you create a script and call it tower?
Yeah, it's because I already I'm working in the same like project as my last one, and when I was setting this up, and so I already have a script called turret.
Oh, okay.
So just to make sure I don't get any like errors, I name mine tower. But and is my screen caught up? Are we good? I created a cylinder,
good.
called it turret, and then added a script. I'm gonna change the name to tower just so it's less confusing. Okay, I have a cylinder called tower and a script called tower that's on the cylinder, and that's all we have so far. Let me pull up my tower script. Okay, so
I think we're losing
this
you.
with the towers again, there's probably a lot of different ways. Are you?
I don't
Can
see
you hear
your
me?
script.
Oh, the script's not open. The script's not open.
Oh, sorry.
I'm still looking at the I'll pull it up right now though. So if you think about, there's a lot of different ways you could probably implement towers. So ideally what we want for this tower to do is to lock onto one enemy, to have that enemy be its target, and then we would shoot projectiles at that enemy. So there's kind of multiple steps to that, right? So we need to figure out a way to have it lock onto the enemy. And as I said, there's probably multiple ways you can do it. I think the way that I just did it was to have it just, it's actually just going to iterate through and see which enemies, the enemies that are around, to see which of them are actually close to it, which one is the closest enemy out of the ones that are currently spawned, and then figure out if that closest enemy is within range. And if it is, that one becomes the target. So because we're implementing it in that way, and we're actually just going to iterate through and check each one individually to see if this game were to go long and there'd be large amounts of rounds, it wouldn't really be good to have that like amount of stuff be in our update function, just because it has to, there'd be put a lot that would have to do each frame, and it would probably slow your game down. So what you can do instead of having it run an update, to figure out to have the calculations be done in update, we can do something called invoke repeating. So if you put that in the start function, and what we do is we pass it the name of a function. So I currently don't have any function set up in this script, so I'm just going to make one up and call it update target. And then we give it, so the first number here is the amount of time basically to start. So when it should actually start repeating. So I'm telling it after 0 seconds, start calling this function. And then this second number will be the amount of time between calls of it. So we can just do it every half a second. That way it's not every frame. All right, so now we should actually make an update target function. So we'll call it void update target. And now we actually should think about what information this tower will need to carry out that function. So let's create some space up here because we need to create some variables. What we're going to do is create one called public transform target. That's lowercase target. And this will basically just, we're just going to give it the object to search for. The next one we want to have is a range variable. So we'll call it public float range. But again, this is arbitrary, the number you put here. I'm just going to put 15 for now. And if it's too high, I'll change it in the inspector. And then potentially, actually, that is fine for now. We can go back to the scene really quickly. Okay, so if we go back to the scene really quickly, nothing should have really changed. But remember, we talked it's about our gizmo before. We used gizmos to show where our waypoints are, even though they're just empty, invisible objects. We can do the same thing with our tower's range. So if we go back to our script, we can add another function called void on draw gizmos selected. And then we tell it to gizmos dot, oh, that's not what I wanted. Let's write it all out. So gizmos dot draw wire gizmos dot draw wire sphere, and then we give it its current position. So this is going to draw a sphere around a center point. So the center point we want is our current position. So transform dot position, and then we give it our range variable. And if we save that, we can go back to Unity. Oh, I forgot a semicolon somewhere. Yep. Okay, there's the semicolon. Now we can go back to Unity. And if you notice, there's this really big white circle now around my turret. That is my tower's range. So like, as you can see, 15 is way too big. It's bigger than my entire stage. So because it's a public variable, I can just change it here and set to like 5. And so that's probably more reasonable based on the size of my level. So let's just leave it at 5 for now. But this is an easy way to help visualize how big your tower's range is, especially if you want to add more towers. That helps a lot. Okay, so now that we have that, we should declare what our update target function is. So what we want to do is, let me create one more variable here, because we're actually going to search for what an enemy is based on its tag. So let's create a public string enemy tag, and I'm going to call, oh, that's the wrong thing, enemy tag, and just make it enemy. So I currently haven't defined that tag, but we will quickly, or pretty soon once we go back to the scene. But we're going to work on the function first and then do that once we go back. So we have a public string enemy tag, and its default value is enemy, but we set it to public just in case we wanted to change it to something else. So in our update target, what we're going to do is take the array of, we're going to create a new array of game objects, and we're going to title it enemies, or I'll title mine opponent since I've been using that for the entire time. Never mind, let's just do enemies. And we'll set this equal to, so now we need to initialize this new array. And the way we do it is by this function here, game object dot find game objects with tag enemy tag. So this is going to search through all the game objects currently in the scene for the ones with the current tag, and then set those equal to, or set those as part of this array. Because we're going to keep doing so many like individual searches, this is why we put it again in its own function rather than in the update function. So we have that. And now what we want to have is a float. We'll call it shortest distance, and this will keep track of the distance that whichever object is close, or whichever enemy is closest to us. I think we probably just set it to 0f. And then we will also want to keep track of which game object is the one that is the nearest to us. So we'll define another game object. We'll call it nearest enemy. And we'll set it right now, it's just set to null since no enemy is currently near to us. And now the way we want to do this, we want to iterate through all of the items in this array, but we don't actually know the sign or the actual size of it. So because we don't know the sign, instead of using a for loop, we're going to use a for each loop. So we'll type for each, and we'll say each game object enemy in enemies. So this will search through all of the objects currently in this array. It will loop through all of them. And we want to check to see if it's closer than whatever our current nearest enemies is. So the way we do this is by, we're going to create a new float called distance to enemy. And this will be our distance to the enemy currently being checked. and we make that equal to a vector 3. Or we want to make it to the distance between. So we're using this function again. We used this function previously. This just gives us the distance between the two vectors, so vector 3 dot distance, and it's transform dot position for our position, and enemy dot transform dot position. And this will give us the position of whatever enemy we're currently being checked. Okay. And now we want to actually do the check. So if distance to enemy is less than the shortest distance, we want to set our shortest distance to whatever that new value is. So shortest distance is equal to distance to enemy. And then we want to set whatever our nearest enemy is to that game object. Nearest enemy equals enemy. Oh, I see why the 0, okay. So this can't be 0. So it should just be an infinitely large number. So we could actually just make it, sorry, math dot infinity, math f dot infinity. That way it's just an infinitely large number and whatever value is always smaller than it. All right. I've been writing a lot so far. So any questions while people try and catch up, or does anyone need me to go back and look at any of the other scripts? What type of object are my checkpoints? They're just empty objects. All they have are transforms. Yeah, all my these are all just empties. All they have are transforms on them. Okay. All right, so once this finishes the loop, what we want to do is set our target, because remember, the reason why we were checking through all these enemies was to figure out our target to shoot at is. So now we actually want to define our target. So if we want to make sure we actually have a nearest enemy, for example, if there aren't any enemies, then nearest enemy will just be null. So we need to make sure it isn't null. If nearest enemy isn't null, and we want to make sure that it's within our range. So whatever its shortest distance is less than or equal to range. If that's true, we will set our target to be the transform of the nearest enemy, the nearest enemy dot transform. Otherwise, we're just going to set our target to null. Okay. So now this is our completed update target function. So it will search through all of the current objects in scene for those with the enemy tag, put them in an array, and then it will iterate through that array to figure out which of those enemies is the closest one to us. And then once it figures that out, it will check to see if that closest enemy is within our actual range. So we're doing 3 things here. First, we figure out which objects are actually enemies. Figure out which enemies are close, and then if it's within range. So one thing we have to remember is we define this, we're checking by a tag. So we actually need to go into our Unity now and define that tag. So if we go back to Unity, if we find our prefab that we made for our enemy, mine's called opponent, we want to tag it. So if you find on the inspector here tag, it's currently untagged. We want to add it. I already created the enemy tag, but if you need to add another one, you just hit add tag. There'd be a list here. You'd hit play, and then you type in enemy. So for example, I'd hit tag. Let's just make a new tag. We'll call it opponent, but we're not going to use it. Make sure you do it however you spelled it in your script, though. They need to be the same. So once we have that, make sure we just tag our opponent to whatever that tag is. So now it's tagged to enemy. If we do that on the prefab, it'll apply to all of them. And that should be fine now. So let's make sure the tower, the target transform, we don't actually need to give anything to it. Oh yeah. So if we hit play, and if you look in your script here on your tower, as the enemy spawn, you'll notice the target changes when an enemy enters its range. So right now it's none, and now it's an opponent, and now it's none, an opponent, none again. So that means it's functioning. Since the reason why I kept it as public was just so we could see if it's working, just because our tower is just a cylinder. Like in an actual game, you probably want an actual turret to look at the enemy, but since we just have a cylinder, we don't need to do that, and it's just going to set that variable. So that's functioning how we want it to. Okay, and now that we have that, I think all we need to do now is actually shoot them. So we're going to need to create bullets. So let's create the bullet object first. And I'm actually going to prefab the tower. So if I take the tower, I can drag it back into my project tab. And now I have a prefab for my tower. Okay. So now let's create a bullet object. So I'm going to create a 3D object, another sphere, and this bullet is way too big. So I'm going to scale it down to a fourth of its size. So 0.25, 0.25, whoops, 0.25 there. And now I have this bullet. I think I made a separate material for that. Oh yeah, I added you can add a material to this tower if you want. I'm gonna give my bullet this gray material. Name it bullet. Actually, I'm gonna name my projectile again just because I already have a script named bullet, so I don't want to create that confusion. So I'm just gonna name my stuff projectile, but there's my projectile. Once I have that, I have this object. It has a material on it. I'll prefab it. So I'll go back to where my prefabs are, drag the projectile down into here, and then like the enemy, we don't actually need this to be in the scene. So I've deleted it. It's not in the hierarchy anymore. It's not the scene. All I need is the prefab. I don't think it doesn't need the collider either. So we'll remove that. So all we should really have here is just a transform with like the mesh, and then I gave it this gray, like black material, and that's our projectile currently. And so what we want to do is create a script for that projectile. So I'll do add component, script, and I'll name this projectile script since I already have a bullet script. Create an add. And then let's open that up. Projectile. Get my notes really quick. Okay. So now what we want our projectile to do. So we could just have it shoot out in a target direction, but then there's a good chance it just misses unless it goes really fast. But to avoid misses, we can just give it a target and have it move towards that target. So it's just gonna like get whatever our enemy is and then follow that enemy until it hits it. That way, like there's no misses and it's kind of easier that way. So it needs a target. So let's create some space up here for its variables. We'll create a private transform and make it target. So this is the target we're going to chase. We could also specify damage, but we can do that if we have time at the end. For now, let's just do public. We give it a speed. Again, this speed's kind of arbitrary. You can change it within the inspector. So we'll just make it public float speed. I'll set mine to 40, but if you think that's too fast or too slow, you can always change it to whatever you want. Okay. So I think we're gonna put the projectile on hold for now and go back to our tower. So our tower needs to be set up to where whenever there is an object in range, it shoots at it. But we also don't want it just to keep shooting forever. We want there only to shoot. We want to have like a cooldown on it. It needs to have a timer. So we need to specify a couple of new variables for our tower for it to be the timer. So first, let's create a public float fire rate variable, and let's set this to 1, so it shoots once a second. And this is public, so you can change its fire rate from within the inspector. And then we will create a private float fire countdown. And this will be the countdown to figure out how close it is to being able to shoot again. And we will set that to 0, since it's current at the start of the game, it's currently ready to shoot. Okay. And now we're going to use the update function for this, since it's easier, simpler. What we want to do is we want to fire countdown. We want to count down. So fire countdown minus equals time dot delta time, like we've done before. That way it's the same on everybody's computer. If there currently is no target, so if there is no target available, we don't want it to do anything. So if target is equal to null, we're just going to, let's just, return. If target is null, return. If the target isn't null, we'll keep going, and we will say if the fire countdown is less than or equal to 0, we want to shoot. So this means we have a target and our fire countdown's it's ready to shoot again. So we'll just create a function called shoot, which we will define in a second. And then once we've shot, we will reset our countdown. So fire countdown is equal to 1F divided by our fire rate. Did I capitalize rate? I did not. Fire rate. That way, if we wanted it to shoot 2 times a second and we set the fire rate to 2, we would divide here and it would shoot 2 times a second. So the countdown would just be set to 0.5 and we'd only have to count down half a second to shoot again. Okay. And now we need to define our shoot function. So I'm going to put it here just so if people still need to see the update, they can. We'll do void shoot. And now the first thing you want to do is create a new bullet. We need to create a bullet, which reminds me, this object needs to know what the bullet actually is. So we need to give it a new variable. Public. This needs to be a game object. We'll call it bullet prefab. And once we give it our bullet prefab from in the inspector, we can call it here. So in our shoot function, we want to create one of those. So the way we do that is by using this function called instantiate. Bullet prefab. And we want it to start at our position. So transform.position and our rotation. So transform.rotation. So theoretically, what this is going to mean is it's going to spawn. Let's just go back to scene really quickly. Save it.
Do we not need brackets
our
around
bullets-
the return?
You don't. So with an if statement, the line directly after it in it is part of the if statement. Every line after it isn't. So
Oh,
that's
interesting.
kind of just the way it is. But the brackets look nicer. So I can do that too.
Can you scroll
The
up to
bracket,
the,
anything you put in the brackets are part of it. Yeah.
oh, can you scroll up to the bullet prefab thing again? The definition.
Right here.
I didn't have the game object thing, so I was just getting it.
Okay, cool. So, I spelled fire countdown wrong in the script, but we're not hitting play right now anyway. I was just gonna say that currently, because we're using this object's transfer not position, the bullets are gonna spawn within the object. So potentially, if you don't want that, you would set a separate empty object and place it just outside of the prefab somewhere and save it to
Do
the
you know what my
prefab.
error is, guys?
What's the error?
Oh, sorry. I meant to ask this,
Okay. Okay, so our bullets are just gonna spawn within the tower, but like, if you think that looks jank or something, you can always change it by just creating a new spawn point and attaching it as a child object to the tower. For simplicity's sake, the bullets will spawn from the center of the tower and just move out from there. So I spelled something wrong in here. What line is it on? 27. Yes, I did. Fire countdown. Okay. So we're in the shoot function. We want to instantiate that the bullet.
Jared, can you scroll up a tiny bit in your code?
Yeah, right here.
Thank you.
So what we want to do, if we kind of think about this, we need to give our bullet the enemy that it's chasing, because our
what's
bullet
the
needs
other
to know what
arrow?
enemy it's chasing.
Oh, sorry.
So right now it has no way to pass that information on. So we want to kind of find a way to do that. So an easy way to do it is actually, we will store this game object we stored temporarily. So we'll call it game object bullet fire is equal to instantiate. So this won't return. I don't think it will return all the way. So what you do is you type parentheses, game object, and this is called typecasting. So it converts the return value of instantiate into a game object so that it can be stored here as bullet fire. And the way you do it is just with parentheses and you type what data type you want. And so we want a game object, so we cast it to a game object. Once we have that object stored, what we will do is sorry. So once we get the game object, what we need to do is get a script on it that's called seek, or we need to pass that information. So let's just put a pause on this really quickly and go back to our bullet, which mine is called projectile again, but sorry about the naming convention. I probably should have split these projects in two. So in our projectile script or our bullet script, we want to create a function that will allow the tower to give it what its target is. So I don't think we need start, so I'm going to delete that out of the way. And let's just create a new function. We'll call it, this one needs to be public, so it can be accessed, public, void, seek. And it needs to pass a certain amount of information. So the information we need is a transform, basically. We need to know where to go. So we give it a transform, and I'll call my transform underscore target just to differentiate from the already target we've defined up here. Once we have that, we put the curly brackets. And then we just initialize our target as whatever that target currently is, what that target was passed to us. Okay. So now that we have this function defined, we can access it through our tower because we have the game object. So the way, I guess, I don't think there's probably more lines than was needed, but I'm just going to copy what I already had. So projectile, I'll write it out and then explain. So projectile, which usually would be bullet if you use bullet instead of projectile, equals sorry, give me a second, I'm looking at the wrong thing. Yep, so equals bullet fire dot get component projectile we want to make sure we actually have the projectile. So if it isn't null, we will call our projectile. Oh, it's bullet fire. No, I'm confusing myself now. Projectile dot seek target target. Yeah, add that later. Okay. So what we did here was we got the script. Because my script is called projectile, I want basically a data type of type projectile. So we're getting the projectile, our script, we're calling it projectile. And we did that through get component. So because we have the game object, we can get that should be capitalized, projectile. We get the projectile script, we store it, and we make sure it's actually there, it's not null. And then we call the seek function and we pass on the target that we currently have up here. Or that we're currently finding through update target. So we find the target and we pass that off to our projectile. So with that, I think our tower is basically done. So the only thing left we have to worry about now is our projectile. Any questions before I move on to this projectile script? If not, we'll just move on. Again, if you ever fall behind, those scripts are completed scripts are there. I think seems like we're good though, so I'm going to move on to the projectile. Okay, so let me pull up that script again. So currently we just have seek, and all it's doing is initializing what our target is. So now we need to actually move towards that target. So we're going to use our update function for that. So the first thing you want to do is make sure the target's actually still hit it, our target would be destroyed itself, and now we would have a null object as our target. I'll pause for a sec just in case. Yeah. Okay, so I was cutting out a bit. I can repeat what I was saying. I don't know if I'm back, but hopefully while I'm repeating, I'll cut back. My internet will stabilize. So what we're doing is, so theoretically, right, if the bullet is chasing the object, right, to hit it, our target, and the target hits the finish line, it destroys itself. So now the target it's supposed to be chasing is null. And if we just program straight through to chase it, we get an error because we're trying to chase after an object that no longer exists. We need to make sure our target isn't null. So if our target is null, we're just going to, we'll destroy ourselves because we don't actually need our bullet anymore. So destroy game object, which is our game object. Got the semicolon, and then we will return. All right, so now once we've checked to make sure our target still exists, we will actually move towards that target. And it's going to be a similar way as we programmed our enemy to move towards the waypoint. So we'll make a new vector3 called direction. We set that to what our position, what the target's position is, minus our own position. And if anyone's curious why we do minus, it's just kind of vector math. So if you want to look into like vector math, something you could, I guess. So that's our direction. And once we have that, we create a we're going to create a new float called float distance this frame. So this is going to be the distance we travel in our current frame. And set that equal to what our speed is, which again we defined up here as a public float, and multiply that by time.delta time. Time.delta time. All right. And then we want to, if our, we want to translate. So let's do transform dot translate our direction. Again, remember we do normalize, so we get rid of the magnitude component of our direction. We only want the actual direction component of the direction. So times distance this frame. And that should be it. Oh, I think you may want to add, if case something bugs out, you may want to add this line afterwards just to tell it within world space, but I don't think it may not be necessary, but just in case, this is something you can add if your bullet starts to like bug out. But we have this, but now we need to actually know if we hit our target. So I'm going to create an if statement between these lines to check if we hit the target or not. So if our direction dot magnitude, basically, if a direction dot magnitude is less than or equal to the distance this frame, target, or we're going to. The reason we're testing the magnitude of the actual is each frame we're moving a set distance dependent on this kind of calculation or speed times the delta time.
Jared, you're
That's
cutting out
how
like
much distance
quite
we
a
move from
bit.
each frame to move that distance. So we know
We're losing you,
if
Jared.
over here, which is the actual like. Am I?
Yeah, I think you have to like go over that
Am I back?
explanation again. It was really choppy. You're back now though.
Okay, yeah. Okay, so a better way to explain this than what I was trying to do was the opposite. So
Jared, we're losing you
if the
again.
direction dot magnitude is greater than distance this frame, the bullet will overshoot the object. Am I back?
I
Yeah,
can
you're
hear you.
good.
Hello. Mic test, mic.
You're good.
test.
Yep, you're good.
Okay, so if direction dot magnitude is greater than.
Oops.
Oh, we lost him. Oh boy.
I'm the host now. It says.
Yeah, Emily, share your screen. Let's go.
It's not. I'm still having my error. I don't know. See, okay, can someone help? Like, oh wait, okay, well, I have an error.
It's okay. We can just wait. We'll wait for Jared to come back. He'll be back soon. In the meantime, how is the tutorial going for everybody? Does anybody have questions? Cool. And if people don't have questions, just a quick plug for team lead applications, which will be closing on Friday. If you guys are even slightly interested, I highly recommend it. It's good for leadership experience, good for your resume. It's good to figure out how pipelines work in general, and that's kind of crucial for game development. But yes, I highly recommend it. If you have any questions, please DM any of the officers, because we all have experience in something like this. Yes.
Also, we're having week 10 social.
Oh, yes, also that. This is not the first time that I'm hearing about this.
I don't have a date yet because, oh, Jared's back.
Yeah?
I can hear you, but we're also in the same Discord call. I don't know if everyone else can hear you. And he's gone. Yeah, Jared.
Hello?
Oh, Jared. Hi, Jared.
Hello.
You're cutting out really badly.
Am I back?
You're back, but you're also cutting out.
All right. That was my internet. That was fine. Am I cutting out again?
I can hear you now.
Oh gosh.
Is the tutorial almost done?
Is it better now or?
It's on and off.
Am I
Peter
good?
said.
Let me show you my screen and see if that works.
Okay. Is the tutorial almost done or?
It was almost done. All we have to do
okay.
is. I had extra stuff we could do, but the only necessary thing we need is the projectile.
Okay.
Okay, I think I'm going to continue. I'm assuming I'm back. I might,
Yeah, you're good, dude.
it might still be cutting out, but just to try again. Okay. Let's see. Okay, so we're gonna call a function called hit target, which we will define. And once we hit the target, we return, since we don't need to check to see. We don't need to move since we hit it. So we'll return. And now let's make our hit target function. So void hit target. The first thing you want to do is destroy ourselves. So destroy game object. And then we want to destroy the enemy that we hit. So let me remember if I changed this in my notes, but for simplicity's sake. So destroy the target dot game object. I think that is how it goes. And if we hit save, let's go into back to our scene. Okay. So my tower needs a bullet prefab to be given to it, which I haven't done yet, so I can drag that in. My projectile, let's hit play. Hopefully that everything works. Yeah, so and then my bullet shoots it and it vanishes. So that's how it, that's kind of a basic tower defense. That's for the most part what I had planned. There were some extra stuff, but since my internet has been
Oh, is Jarrett deceased yet again? Yikes.
Uh-ohs.
R.I.P. Jarrett.
This is a really sad tutorial, guys.
So anyone try to comment? I mean, I don't know.
I mean,
I mean,
I could always use a spare RTX 3060 Ti.
I mean, if you guys want to sponsor us, I ain't gonna say no. Oh, Jarrett's back. Hello, Jarrett.
Hi, Jarrett.
Oh.
Can you hear me through Zoom?
Yeah.
Yes.
Okay. I don't know if you saw any what I just did, but like we only need like 2 more lines and it's done. So like
Okay.
let me try and
We watched it semi-work.
okay.
Yeah.
So as long as your guys' projects are they're spawning, the enemies are spawning, and the enemies should just be one shot. Like if the bullets are spawning, hitting the enemies, I can pull up my projectile tab really quick. So I think I added this hit target with return, and then I added the hit target function, and that should be it. That's the basics.
Oh,
So,
okay. We watched that successfully.
Okay, so that's basically what we had planned. There were some other extra stuff I had, but since my internet's going out every 5 minutes, I don't think I'm gonna be able to do it.
Oh wow, so I see it in my game. It shoots every single like purple ball. Or not all of them, but shoots some of the Oh, it doesn't shoot every purple ball.
Well, that's because it shoots on a delay. It has like a reload speed.
Oh.
So you can change that if you want, or
That's
just
okay.
because normally, like, I guess some things you could try and implement yourselves if you wanted to would be to implement other types of towers or other types of enemies. So an easy thing to do, since if we want to make another type of enemy, for example, like that sniper one I showed earlier, we can just duplicate this tower. I'm gonna change its name to sniper tower. Let's find this sniper script. I'm gonna change its range to like maybe 10, and maybe its fire rate to like 0.3 or something. So it has like a lot less fire rate, but much more range. I'll move it somewhere else, and then take our sniper tower and make a separate prefab of it. And when it asks for you to do a prefab variant, or say prefab variant, and now we have a sniper tower that functions differently. That's an easy way to use what we've set up. But if you want to challenge yourself and do other types of towers, like maybe a tower that shoots multiple enemies at once or something, that could be another thing you could try. The video today, but yeah, so this is basically a basic tower defense game. Thank you guys for coming out. If there's any questions, I'm gonna stick around, but my internet probably won't let me stay for very long. So thanks everyone for coming, and hopefully we'll see you next quarter. Oh, remember, if any of you want to be team leads, the form is out. I don't know if we am I gone? I think I'm gone. Shoot,
No,
I'm
no,
gone
you're
again.
here. You're here. We
We
got
already
you.
we gave
Okay,
them the
I'm still
announcement
here.
as you were gone. They know.
Oh, okay.